I think yeah, okay, ready to start. So hi all, I'm Emanuel, I'm a principal engineer at Infobip, and so maybe I'm gonna say something controversial, but I believe doing research within a company creates real value. I mean, this is like often seen as, okay, something that is like too slow, maybe too expensive, but like today, I want to like show you the lessons that we have learned from research on spam detection, and actually, in the end, like how we, in the end, did create value. So, like, I mean, we know that like there is this like natural tension between people like who do research and like people who are really like focused on like product development. So one really like focuses on discovery to understand and know like, okay, why is something happening and how and why does it work? And while the other side is really like focusing on delivery, like we want to build fast, we want to like ship it as fast as possible. And yeah, so there are basically different viewpoints. And now, I mean, the question that you have to ask yourself is basically, so, okay, how do we bridge this gap? Or maybe like even better, like should we bridge that gap? So yeah, depending who you ask, you're gonna get a different answer. So if you ask Elon Musk, like he will clearly say no. So like yeah, okay, there is they agree. So from his perspective, okay, like we don't need any research. Okay, so maybe in this case, like okay, this talk can be over. But maybe like if you go like a bit talk with some others, like Jan LeCun from Meta, he will have something to say on that. So like and I think like he will gladly go into a debate with you and really tell you, okay, why this is important. And basically, yeah, different viewpoints, different things to measure, and overall it's a different. So both of those things you need. And now the question is, okay, like okay, if you say yes, let's the research something that you need. I will show you actually 4 different tactics that like you can apply and that we have applied in our own case that in the end like really brings value. Okay, so basically now that you say you want to do research, tactic number 1. So the thing is like you have to guide your basically research roadmap that it aligns with your business value. And overall, like let's say your business roadmap and the plan that you wanna do. And now, like I would say, like this is easier said than done. So that's not an easy task. You really have to like understand your business to see what's the value, and also like understand overall like the different like research topics. But like this is like one of the first things that you could do. And like okay, this is not something that I have come up with. So others have done it from Spotify research, Microsoft, Google. But that's one of, I would say, the key things first that you have to do. Okay, so in our case, so like those are our research topics that we have mapped out, and basically, so this is what we said. Okay, these are the things that we want to focus on, that's where we want to do research, and those are the things that will provide us an additional business value. And again, like depending how granular we are, you could even like maybe aggregate them, make them less granular. Like in our case, it could be like conversational experience and like network security, those 2 topics. But overall, like you have to basically have them planned out because like this is something that maybe like you will invest some more time. Okay, but then once you got this, then you can go to tactic number 2. And basically you should strive to collaborate and really strive with partnerships, and also from academia and industry. The thing is like, okay, what you wanna have always like some kind of like fresh perspective, where because it can easily happen that you fall into like your own filter bubble, and in this case, basically you want to like have a way that maybe like you find something else out and you have on a different like viewpoint. Basically, and you can do this with maybe like inviting visiting researchers, maybe trying like to have a place to co-author publications with different partners. But overall, you want to have an environment where you do some kind of knowledge transfer. And so, here again, like in our case, this is like what we are doing. So we are like collaborating also like with different academic partners. And now, okay, you can still like say, why is this important? But yeah, I want to actually convince you that this is really good, something good to do. So because like the next part of this talk that I'm going to talk about is actually a success story that we have done with the collaboration with one of our academic partners from Graz University of Technology. So again, like in our case, we basically said, okay, let's focus on the topic of spam filtering, and this is something that we really wanna like push the frontiers, to be the ones that are like conducting state-of-the-art research, and try to then again find out what's the business value for us. And basically, again, like now you decide the topic, but like if you go a bit further into spam detection, like there are different things that you can do. You will quickly find out there are like different types of spam. Is it like maybe like phishing or some like scams with like some fake prizes, maybe explicit content, maybe it's like different kind of modality. Is it textual? Is it maybe images? Is it like AI generated voice calls? So there are different things that you can research on. But overall, like, okay, the question is now, what should you focus on? And basically, this brings us to tactic number 3. So from a product perspective, I think like that's natural. You want to have as fast as possible something out there, you want to deliver it, and you want to have something that works. Again, you have now this like research perspective where like you will usually like take your time, really try to investigate the problem and really find out, okay, what's here the best solution. And like, yeah, okay, the trick is here that you have to find like the right balance between like, okay, what works and like what has the maybe highest potential that it will generate some value, and this is the time that you're gonna invest in. And so I'm not saying here how you do it. So it's just like you have to do it. So that's your own process. That's again like in our case also this is also like iteratively looking into, okay, how can we maybe like prioritize some topics versus some other ones, and this is a joint collaboration always. Okay, so basically So in our case, what we did, we found that, okay, within MMS traffic, like it's basically images are being sent. This is something, analyzing images is not like that easy and straightforward to do, but it's something that actually is beneficial for this topic of spam detection, also from our business. And yes, I know, you will probably now, you're asking yourself like, okay, who is sending MMS? I would ask you for a show of hands, but I think nobody will here show their hand. But like, it's still a significant part of traffic that is being sent. So we found basically, we said, okay, this is a research topic that we are going to investigate. So what we did, we looked, okay, what are basically recent research doing on it? So we found like one research paper which was on the topic of spam detection, and this is then what we said, let's go try to analyze this and see if it helps our own business. Okay, so when we look at the paper, we saw, okay, there are like different spam categories being defined. They don't match like one-to-one to all our use cases, but overall, like it was a good start, like in the right direction. And also one thing is that, so in that paper they compared like different machine learning models, and I think like, I mean that's like maybe now it's like not surprising to most, like the clear winner of all that like experimentation was GPT-4 vision at that time of the paper, and so this is cool. Now you could say, okay, we don't need to do any research, like let's apply it. But the thing is, like for us to apply this in a commercial setting on a scale, this is like not that good, because this is the first thing is like, okay, we have then a much higher financial burden, but also like from a latency perspective, like it takes too long to analyze all the images on our traffic to be realistically usable. So basically, in our case, although this was a good like experimentation, but like it's not usable for us. So, and another issue that then you also maybe like have to think about, okay, because like you're using some kind of model over time, and OpenAI brings a new one, the next time, like in a few months, there comes another one. What we did is like we tried to reproduce the results of that paper. And at that time, like this GPT-4 vision, it was actually deprecated, so it didn't exist anymore. So what we could do is the next available model, the newer one, was GPT-4o. So we actually then tried this out with GPT-4o. And the thing is, like, we didn't get consistent results. So it would be good if they're better, but like not all of the like spam topics that we covered weren't better. So again, in our case, like for us, it's important to have like this kind of reliability. But you have to be aware that like this drift and model performance is something that that can happen and that is happening, even like if the same model happens, but maybe like if you're just using some kind of API, like under the hood, something is different, and you're not going to be aware. So you have to be aware that's just a thing that basically is happening. Okay, good. So now we know this. Okay, we did this research paper, and like from a research perspective, like okay, so what's the approach that you would now do if I would ask you? And I think the answer is actually pretty simple one, because I think we heard it this last few years a bunch of times. The answer is always transformers. So this is like the most popular now architecture that is being used in deep learning and applying to anything and almost any kind of modality. So one of the things that you have to be aware for like in images, like also like people have tried like to use transformers like for images. The problem is here, if you take an image and I don't know, say it's 224 pixels and 224, and you try to like tokenize it, you pretty fast get like I don't know 50K sequence of tokens. So it's computationally like the computational burden is a bit heavy. So one of the like recent key breakthroughs that has happened here is this was like one paper from like an image. It's called like an image is worth 16 times 16 words. Basically, like the key breakthrough here is that okay, you can basically split like the image in like multiple patches of like 16 times 16 pixels, and then like each of those patches is one token, and then like with positional encoding, you can basically then put this into your transformer, and like now this has actually pushed the whole like frontier with visual language models to get much better. So this was one thing that has already happened. The second game changer actually came from OpenAI when they like released like their clip model. So it's basically like it was trained on like 400 million like image and text pairs from web using contrastive learning. So if you're not sure like what this means, is basically you show the model like a bunch of different image and textual caption pairs, and then like you're trying to learn the model where those images and textual content that belong together are somehow like pushed together into the embedding space, and that which don't belong together are like pushed far away. So this is like way how you try to learn that model. So and this is what they did, and it's one of, I would say, one of the really popular models for like vision in the vision domain. But one cool thing about it is that basically once you have that, so already like in just by using that model in this zero-shot manner, you can just like put an image and ask it, okay, like what's on that image, like what should I do, or maybe like try to do some kind of like classification. Okay, this is an image of a dog, of a cat, or whatever. So, but it's pretty useful, and this is after that like the whole like area of like this vision language models has also like exploded actually quite a bit. Okay, so again, like as researchers, what we did, we like took those models, also like added an additional one, which was trained on different like vision tests, and we said, okay, let's try now to beat GPT for vision. The first thing what you do is usually like, okay, try to use it in a zero-shot manner. So basically, took the models as they are without any retraining, and yeah, of course, they're not better, but you have to do that kind of experimentation. But one of the, I think, most popular things that you're doing nowadays with those like vision models is basically you're adapting this like one part of the architecture for your out of domain task, and then like you train it with basically your own data from your domain, and then they can basically solve your own tasks. So in our case, and this is done by pure like empirical research, we came up with an architecture. We have like one wide layer for like expressivity, then a middle layer for like two more generalized results, and then like the head, which in the end like can tell us this image is basically some kind of spam, or basically it's one part of one spam category or not. So and then basically by doing it in this way, you can actually fine-tune it with also like a reasonable amount of data. You don't need like really vast amounts, but also like you can do it fast, and like you end up with also good inference time. Okay, so and indeed like this is what we ended up. So we actually then basically used the data set from that paper, compared it also, and came up with, okay, now this is something that like works better in this one case. But the most important thing is like, okay, this now tells us that this is something that can provide value. Now we can go to the product team. Now we can go to the necessary stakeholders and tell them, hey, look, like we were able to come up with something that like should like really work in our production system. Should also like be maybe like doesn't cost us that much. Now we can maybe like think about building and shipping it fast. And the key, I think, like the key message here is that so we wouldn't come to this conclusion if we like didn't plan our research roadmap. So this was tactic number 1. If we didn't collaborate with our academic partners, so tactic number 2. And also like if we didn't prioritize this research task, which was again like this tactic number 3, where you have to find a balance. Sometimes, okay, you're gonna go more like to push like whatever is faster to build, but sometimes you wanna also investigate problems which you're not sure like if you can tackle or will generate you any kind of benefit. But again, like in our case, this was the result here. So, and this then basically brings me to tactic number 4, this last one. So the thing is like, okay, great, you did your research, but basically you need to test it with real data under your product constraints. And this needs a lot of like collaboration, also like with internal teams, and you basically need to have like also like multiple feedback loops, because only then you're gonna end up really with something that is usable, because now comes the real part where in the end like you're trying to push it to production to solve your real problem and then really then generate that one business value. So and we did this actually in an iterative manner. So this is not something that's like, okay, it's gonna just like come up. So we collected multiple open source data sets, which we tried to like gather, and then like we build like several models, or like every iteration try to like aggregate more and more data sets from open source, and then whatever we find that it's spam, we try to then identify and then additionally relabel with our human experts. So like one of the like technologies that you can use like label studio, this is like what we use, where then in the end like we can ask human experts that they say, okay, listen, this is what we flagged, that this kind of spam, is it really or not? Basically the whole thing is like you want to iteratively come to a final quality set of data that you can use to find your last model, and also like to come up with really a machine learning model that can then again solve your task. In the end, so yeah, like we came to like basically in this process to to a new data set basically collected from different like open sources, and look, in every iteration basically we fine-tuned additionally like our own model that was better and better, and then we stored, as I said, like the data to be again relabeled. That in the end, like we come up with like one data set for training, and also like several data sets that we can use then for benchmarking. So why this is important? Because okay, now we think that so we have done like some kind of we now have like our model and that's everything. But for future, you want to always like have a way to like benchmark newer approaches, newer algorithms we come up. So you want to have a way to like test this out, and this is then will really help with robustness. Okay, so in the end, basically what's important that so we ended up with a model, and like this is maybe like what you can see, like this big table. You don't need to read everything, but overall, like those left part, these are like our 2 benchmarks. And for the different like spam categories, we managed to get like a comparable accuracy to GPT-4o. And so this is in our case really good, because the kicker here is that it's actually happening at a fraction of the cost. So usually you would send for every image like the request to GPT-4o, but now like okay, we don't need to do it, because instead of like paying for every request, we can set up a Kubernetes environment, and basically one instance with one CPU, 2 GB of RAM, can with also like bit auto scaling, can then handle up to 400 requests concurrently. So this is something that then also that we could scale. So it's much better for us to then use in our own environment. And I think the much better here, what you see in this one lower table is much better improvement is that it's even like 2.34 times faster than just by calling an API for GPT-4o. So in our case,